So for the convex constraint problem, we have a very important if and only if condition. So basically, let's say x star is a minimizer of f over convex constraint zx. So fx prime is less than or equal to fy for all y in the constraint set. If and only if gradient of fx star transpose x minus x star greater than or equal to 0. So this if and only if condition can be easily checked from the convexity of function f. So from the convexity function f, we have this inequality. So this directly comes from the convexity of function f. So we first check that when this condition holds, so when this is true, so basically we can just simply plug in this part greater than or equal to 0. So we can conclude this is true. The next one we have to check is when this is not true, when this is not true, this is also not true. So let's assume the gradient of f x star transpose x minus x star strictly less than 0. Then which means x minus x star is the decreasing direction for function f. So when you set the inside function f is the input of function f is x star plus very tiny t value times x minus x star, then this value will be in the convex constraint set x. And also from this property, we can say that fx star is greater than fx star plus t times x minus x star. So this part does not hold. So from this very simple argument, we can say this if and only if condition is true. Okay, the next one is very important properties of projection. Okay, so we have to remember these two properties. So I think it is very easy to memorize these two properties if you draw a simple figure. So there is constraint set x, and let's say this is point x in the convex set, and let's say y is outside the convex set, and this is the this is the projected point, so pi x y. The projection is the closest point in the convex set from point y to the point y. So there is tangential line here, and we can draw a vector to y from the projected point. And usually the angle should be the angle should be orthogonal, the 90 degree. Okay, and then x is here. So when you draw a vector from the projected point to here, then definitely this vector and this vector will have some kind of opposite direction. So when you think this reference line, this vector is orthogonal to the reference line, this tangential line, and this is opposite direction. This vector located opposite side of this vector. Okay, so let's say this is u and this is v vector. Then definitely the inner product between u and v must be negative. So this is the first property. Okay, and since the inner angle between this v vector and u vector is greater than 90 degree, when you draw this line, u minus v, from the Pythagorean theorem, we can definitely have the u vector length square plus v vector length square must be greater than or equal to the length u minus v square. That is the second property. Okay, so more formally, since the projection is a minimizer, it's a convex function d the distance function over constraint set x. So from the previous slide, the if and only if condition, we have this. And since the gradient of d function is 2 times x minus y, from the gradient we have this. The second property is also very easily can be shown. Let's say v is this vector and w is this vector. From the property 1, we know that the inner product between v and w is negative. And this one is very simple trick we frequently use. 2 times v transpose w is equal to v square plus w norm square minus v minus w norm square. So since we know this is negative, we have v square plus w square less than or equal to v minus w square. That is second property. Okay, so these two projection properties are very important for remaining lecture.